Hi guys, let's take a look at the inside of a bone. What do they look like? I know they look like they're solid, but there's actually lots of little holes inside. So let's see how bones are made up. So this is Microscopic Anatomy of a Bone 4-4, and I think there's like 3 more after this. Okay, we are going to first look at the functional unit of a bone, which is called an osteon. An oste, there's that base word again, that means bone. An osteon, otherwise known as the Haversian system, is the structural unit of compact bone. So here's one right here. You can see it's they pulled one out so you can see what it looks like. But this little circle right there, that one right there, that one right there, those are all called osteons. They're made out of cylinders parallel to the long axis of the bone. So here's the long axis of the bone, and these are the cylinders, and they all stack nice and neat in each other, kind of like those little Russian stacking dolls. Now each of those little circles of the osteon is called a lamella. So with an A ending means one. Lamellae with an AE ending means more than one. So lamella, lamellae is each of these little rings. So there's a lamella, and there's a lamella. And they don't always have 3. It all depends on which one we're looking at. It could have 1, it could have 5, or 10, doesn't matter. So I kind of think they look like little tree rings, and it's not, you have however many, how old you are, it doesn't work like that. It just looks like them. And what we find inside of each lamella is collagen fibers, which gives bones a little bit of flexibleness, even though it doesn't seem like they have any, but they do. And what's interesting about them is that they run in alternate patterns. So these ones go this way, these ones go this way, these go this way, these will go that way. And what that does is just helps to reinforce the strength of the bone and make them compressible in any direction. Okay. Inside of an osteon, we have a little hole. The little hole is called a Haversian canal. So the definition, a small hollow opening in the middle of the osteon containing blood vessels and nerve fibers. So we can see it going straight up and down here. So the red and blue, arteries and veins. There's one here, and I'm sure there's one back there, but we can't see it. And so you have these holes inside of your bone where blood vessels go. So when you break your bones, they bleed because there are lots of blood vessels in here. Now the Haversian canals go parallel with the bone. And then we have these things called Volkmann's canals, which go at 90 degrees, right angle to the Haversians. So here's a Volkmann's, there's a Volkmann's, there's a Volkmann's. And what they do is they just kind of help to spread out the blood vessels. And so you can see that they're all actually interconnected. So he's connected to that one, connected to that one, connected to that one, like that. Okay. Now also in the osteon, we have osteocytes. Now remember, cyte means mature cell. So these are your mature bone cells that live in little houses, little holes called lacunae. Lacuna if we're talking about one of them, lacunae if we're talking about 2 or more. So lacunae are these little empty houses for the osteocytes to live in inside of the osteon. So what we're seeing here, these little black areas right here, those are the osteocytes, and we're just assuming that they live in a little hollow hole called a lacunae. Here's a Haversian canal, there and there. The lamella, pretty much if you just connect the osteocytes like this, you can kind of see, see the lamella pop out like that. So there's one there, there's one there, like that. Okay, now, one of my favorite words to say is this one here. When the osteocytes, which are the cells, when they reach out, they have these little finger-like extensions that spread out, and they can talk to each other, and they can touch each other. So this osteocyte can touch this one, and these little bitty canals that they have inside of the bone to be able to reach each other is called one, a canaliculus. More than one, canaliculus. Sorry. It reminds me, last time I taught this, there was a kid who said it sounded like, can you lick your eye? And so now every time I say Canuliculi, I think, can you lick your eye? Anyway, so Canuliculi are these little teeny tiny thread canals that reach out from the osteocytes and help them to communicate and talk to each other. Okay, so hair-like canals that connect the lacunae to each other and the central canals. Okay, the osteons have rings around them, have little rings around them like this, which we call the lamellae. And the lamellae come in a couple of different varieties. So these make up the osteons. The lamellae make up the osteons. But there's other ones as well. There are some, like if you notice here, it kind of runs into this osteon, so it doesn't get to make a full complete circle. Those guys we call interstitial lamellae. So they're not part of an osteon. So they don't make perfect little circles. They just kind of fill in the blanks. And then we have some called circumferential lamellae, which means they go around the circumference of the whole entire bone. And they kind of they're the packaging that wrap up all the other little guys inside. So we have the lamellae of the osteons, like this. Let me put 2 on there, make it make sense. And then we have the interstitial lamellae, which don't really fully, they're not full circles. Oh, it looks like a bug face. And then we have the kind that go all the way around the whole entire bone, and those are the circumferential lamellae. Okay? Alright. Now, spongy bone is a little bit different. It's got some of the same basic structures, but they just refer to them differently because they're found in compact bone. In compact bone, I'm sorry, spongy bone. Let me try that again. In spongy bone, we have the little trabeculae. If you remember the arches, like that. Remember, trabecula means little beams. So the spongy bone has the trabeculae, AE, plural. That means that they align themselves with the stresses of the bone. So if the stress is coming this way, there will be one that goes like this. If the stress is coming this way, there will be one like this. And so no matter where the stresses come from, the trabeculae will have one in that particular arrangement. And so the spongy bone then is just full of these little beams, and inside of the beams, if we look closely, they have osteons as well. See? Little circles, so they have lamellae, they have osteocytes. The only thing that they don't have is a Haversian canal in the middle, like this, because the blood and nutrients are just going to diffuse on through. So there's no need for a big blood vessel to be going through every single one of these. So in the spongy bone, in the trabeculae, it looks just like the long bone. The fact that it's got the rings and it's got the Canuliculi, it's got the lamella, it's got the osteocytes, it's got the lacunae, it's got all that kind of stuff. The only difference is no big Haversian canal for the blood vessels to get through. Okay, let's see. Spongy bone is just a few cells thick, contains irregularly arranged lamellae and osteocytes interconnected by canuliculi. So just the same as before, just in much smaller scale. Okay, here is a picture, just kind of showing you everything. So this is all just long bone. So here's an osteon, just one complete circle, has several lamellae in it, has a Haversian canal, which contains blood vessels and nerves. We've got osteocytes, which are the cells that talk to each other and are connected through little bitty canals called canuliculi. Then the Haversian canals are connected to each other by Volkmann's canals, also known as perforating canals. We'll just call them Volkmanns. Let's see, what other interesting things? Oh, and then the spongy bone has their trabeculae, have osteons as well, but they're irregularly shaped and they don't have a vessel in the middle. Okay, I hope that made sense to you. If not, ask me some questions tomorrow. Up next, bone development, how our bones grow. See ya tomorrow. Bye-bye.